Great. Okay, so figure above shows the graph of f prime, a twice differentiable function f. Great. On this interval from -3 to 4, the graph has horizontal tangents at -1, 1, and 3. And okay, so the areas of the regions bounded by the x-axis on the intervals are 9 and 12. So they're giving us the area that's in between the graph and then that x-axis. And then we want to now find all x coordinates at which f has a relative maximum. Give a reason for our answer. All right, so what x values could be our critical points? So let's just start with that. What are our critical points? So part A, let's just say we want to define our critical points. What are our critical points? Critical points are where f prime of x is equal to 0. So our f prime of x is equal to 0 at x is equal to -2, 1, and 4. Does everybody agree? Yes, no? Awesome, great. So now we want to figure out what is going on with our derivative here. So I'm going to go ahead and graph. I'm going to make my little number line. If you've been with me for a little bit, you've seen me do this. All right, this is my f prime number line, and I know to the left of -2, my derivative is positive. All right, in between -2 and 1, my derivative is negative. In between 1 and 4, my derivative is still negative. And then I don't have any idea what's going on past 4. Okay, so I know that going from positive to negative, this is my relative mass. All right, this one would be a critical point, but not a max or a min, because the derivative does not change sign, and then we simply do not have enough information to evaluate f prime of 4. Does anyone have any questions about that question? Okay. Okay, on what intervals is the graph both concave down and decreasing? Okay, so let's start with the easy part of this. All right, we know that a graph is decreasing when f prime of x is less than 0. So we know that it is decreasing when we have -2 to 1 and 1 to 4. Everyone agree with that? Awesome. Okay, so now what about concave down? All right, so concave down, all right, this is a second derivative thing. All right, so we know we have a graph that's concave down when f double prime of x is less than 0. All right, so we want to know where is the derivative of the derivative negative. All right, and I'm going to take advantage of the zeros that they gave us here, where we have these horizontal tangents. All right, so the slope here is going down, up until we get to -1. So I know that this has a negative second derivative. All right, so I know that I'm going to be concave down from -3 to -1. All right, I'm going to be concave up from -1 to 1 because the slope of that piece, specifically of the derivative itself, is going up. It's increasing. All right, and then I am going back down from here to here. So I know I'm concave down again from 1 to 3. All right, and then I'm concave up from 3 to 4. So now I just have to match between here. So I know that I am decreasing and concave down. So I am both from -2 to -1. And then it looks like 1 to 3 is common. All right. Does everyone agree with that answer? Does anybody have any questions about that question? Okay. All right. Everyone doing okay? Yes, no in the chat box. Fantastic. Okay. That's not what I wanted to do. Okay. So find the x-coordinates of all points of inflection of the graph of f. I will give you guys a second. I'll give you a head start. All right, I want you guys to try to solve it. All right. All right, so your points of inflection are when f double prime of x is equal to 0 and your sign is changing on f double prime of x. All right, so I'm going to make a number line very similar to the one that I did for the first derivative, but now it's my second derivative. All right, so I know I have my horizontal tangents at -1, 1, and 3. Those are my zeros of the second derivative. All right, and then the second derivative is negative. Here, we discussed that. Slope is negative. Slope is positive. Slope is negative. Slope is positive. All right, so we're changing sign at each transition. So you have inflection points at x is equal to -1, 1, and 3. Does anyone have any questions about that question? All right. Given that f of 1 is equal to 3, okay, we have a question. How did you know? We have a couple questions. Great. How did you know to use -1, 1, and 3? Okay, so the derivative, the second derivative is we're going to have an inflection point when the slope of the line tangent to the first derivative is 0. All right, and so that would be there, there, and there. So maxes and mins in the first derivative would be zeros in the second derivative. Can we also say these are inflection points because the graph of f prime goes from increasing to decreasing and vice versa? Yes, those are equivalent. All right, so everyone go ahead and write an expression for your derivative, your integral. All right, I'll give you guys a second. So keep in mind this is about, this is a little faster than you want to go through your questions next week. All right, you got about 25 minutes for one, you get 15 minutes for the other, so we are about on pace here. All right, everyone got something written down? Ish? All right, f of x is going to be equal to where I'm starting, which is 3, plus the integral from 1 to x of f prime of x dx. This is essentially the fundamental theorem of calculus. All right, I'm starting where I'm starting, and then to get my the value of my function, I'm going to integrate from the x value I start at to wherever I want to go. All right, everybody okay with that setup? Okay, great. So now let's go ahead and evaluate the integral. So I think the easy one is the f of 4. All right, so f of 4 is going to be equal to 3 plus the integral from 1 to 4 of f prime of x dx. So they tell us from 1 to 4, this area is 12. Okay, this area is 12. All right, so this is 3 plus, now do I write 12 and then get 15? Is that what I do? Do I put a 12 there? So we would say no. We do not put a 12 there because this area is below the x-axis, so this is actually negative 12. That area is negative. You can think of the height as being negative. All right, so we should get negative 9. So f of 4 is equal to negative 9. All right, and then now we want f of negative 2. All right, so f of negative 2, we'll set it up the same way. This is equal to 3 plus the integral from 1 to negative 2 of f prime of x dx. They tell us in the question that this area is 9. All right, now my integral is flipped. All right, my bounds are not from least to greatest, so I have to flip it upside down. So negative 2 to 1, f prime of x dx. As soon as I do that, all right, I have to change the sign of that integral to a negative. All right, if you don't change the sign to the negative, you're going to get it wrong. All right, so in flipping the bounds, I take the negative of the integral. All right, and then I know that that area is again below the x-axis. So that is 3 minus a negative 9, which is equal to 12. All right, does anyone have any questions on that question? All right, I'm going to pause. Make sure everybody's got that. Feel free to screenshot if you need to screenshot that. All right, everyone okay if I erase? All right, I'm going to erase. And 3, 2, 1, erasing. All right. Going back a year to 2014, same type of question. Similar type of question, not exactly the same. All right, everyone take a minute and read the question. All right. Okay, we have a function f that is on our closed interval from -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. And we want g to be defined as the integral from -3 to x of this function. And so we are asked to find g of 3. Okay, so for part A, g of 3 is equal to the integral from -3 to 3 of f of t dt. All right, so, all right, not as clean. So I am going to go ahead and split this up into 2 integrals. The first is going to be from -3 to 2 because that would be all of the positive area. All right, and then the second one would be the integral from 2 to 3, and that's going to be my negative area. All right, and then I'm going to hopefully approximate this pretty well with some lines. Okay. That's kind of straight. All right, so for the first integral, we have a triangle. The area of that triangle is 1/2 base times height. So 1/2, the base is 1, 2, 3, 4, 5. And then the height is 1, 2, 3, 4. So this is 10. All right. And then the second one is also a triangle. So 1/2 base times height, except my base is 1 and my height looks like it's -2-ish. All right, so this comes out to be -1. So this should be 10 minus 1, which is 9. All right, everyone okay with that? Does anyone have any questions about that question? Great. Okay, so very similar type of question to the last free response that we did. On what open intervals is the graph of G is the work that you showed enough explanation to get full credit? Yes. It's a good question. All right. On what open intervals is the graph of G both increasing and concave down? All right, so very similar. We know we're going to be increasing when the derivative of G, which is what we have graphed, is going to be greater than 0. All right, so increasing when G prime of x, which is equal to f of x, all right, by the definition here that they gave us, is greater than 0. So we know we are increasing from -5. We hit a 0 at -3, and we are then still positive up until we get to 2. All right, so now concave down. This is when G double prime is less than 0. So we want pieces where the slope of the line tangent to the graph here is negative. All right, so it looks like we're going to be concave down on the piece from -5 to -3. All right, this is positive, so that would be concave up. All right, it looks like this is then sloping down all the way from 0 to 4. Okay, and then we just have to find, again, the common intervals. So, let's see. What did I do wrong? That's a -3. Okay, so our common intervals are -5 to -3. And so 0 to 4 and 0 to 2 would be 0 to 2 is contained in 0 to 4. So we would say 0 to 2. And that would be our answer to part B. Does anyone have any questions? And again, that work is perfectly fine for receiving full credit. All right. So the function h of x is equal to g of x over, can I explain how you found g prime again? Yep. So g prime is the second derivative of g, which would be the first derivative of the derivative. So I was just taking the tangent line of each of these little pieces here because this is your first derivative, right? This is equal to g prime. Does that make sense? No, I know. So this is g prime. G double prime is the slope of g prime. So I could actually go through and find g double prime for, everything here. So g double prime on -5 to -3 is the slope of this line. All right, the slope of this line looks like it's negative, going -2 over -2 is -1. So g double prime here is -1, and so on. Does that make sense? No problem. Okay, the function h of x is this thing. We want to find h prime of x. All right, best way to do this is to evaluate the chain rule first and then plug everything in. So h prime of x, I have to use the quotient rule. So low d high minus high d low, which is 5, over 5x squared. All right, and then let's see, I'm going to choose to simplify this a little bit. All right, so this would give me g prime of x over 5x. I'm splitting this between the two terms. And then g of x over 5x squared, just a little algebra there. Okay, so now we're going to go ahead and plug in my 3. So h prime of 3 is equal to g prime of 3, which I can just read off of the graph. Okay, so g prime of 3 is -2. All right, so -2 over 15. And then g of x, now that's more interesting. Oh, never mind, we actually just found it. So g of 3 is the integral of -3 to 3 of f of t, right? We actually found that in part A. We found that to be 9. So this is minus 9 over 5 times 9. Okay. All right, and then you are not obligated to simplify it. You could leave it like that. But if you do choose to simplify it, you would get -1/3. Does anyone have any questions about the quotient rule or the chain rule there? How did you find g of 3? Again, we did it in part A. So it was the integral, and we just found the area under that curve. Yeah, no problem. Awesome. Okay, p of x is equal to f of x squared minus x. Find the slope of the line tangent to p at the point where x is equal to -1. So again, I'm going to go ahead and, well, let's first find the point. How about that? So p of x is going to be equal to f of, let's see, -1 squared is 1 minus a -1. Okay, so this is f of 2, which looks like it's 0 to me. All right, so the point that I'm going to use is -1 and then 0. All right, so that was the point that I needed. Now I need to find the slope. In order to find the slope, we are just going to take the derivative of this thing. All right, now here, again, you want to use the chain rule first, and then you can evaluate it. All right, so p prime of x, this is going to give me my slope, is f prime of the argument stays the same, times the derivative of the inside, which is 2x minus 1. All right, so then p prime of -1 would be f prime of 2, again, times -2 minus 1. All right, so now I have to find f prime of 2. All right, so that is going to be the slope of this line. All right, I know that this is the point 0, 4, and then I have the point for -4. So the slope here of f prime, slope f prime, is change in y over change in x, -4 minus 4 over 4 minus 0, -8 over 4 is negative 2. That looks right to me. So this is negative 2 times a negative 3, which is 6. Okay, so this, we did all that work just to find the slope that I need to find the tangent line. So then for the tangent line, you need your point, you need your slope. Y minus y1 is equal to mx minus x1. Plug in your point, plug in your slope, and you're done. All right, so lots of moving parts to that question. Anyone have any questions on that question? Since they asked for, so find the slope of the line tangent to the graph. Okay, so I should read the question. They just wanted the 6. You should also read the question. All right, if you read the question, you would have gotten 6. Nice catch. I saw tangent line and I got excited. All right, any other questions? All right, so we're doing great. That was, again, we're faster than pace that you would need tomorrow, next week. Does anyone have any questions about the exam in general?